So in chemistry, we have these things called chemical equations, and they represent what's going on in a reaction. Now, here we have a chemical reaction, an equation, and this is the combustion of methane gas. CH4 is methane gas, otherwise known as natural gas, the same thing that happens in a Bunsen burner. And we take the CH4, which is methane, and we react it with two oxygens, oxygen gas being a diatomic, which means it has two oxygens, and then we get carbon dioxide and two water molecules. Now, there are several things about this reaction. First off, when we look at the individual molecules, this 4 means 4 hydrogens. And there's an implied 1 right there, so that means 1 carbon. And then we have over here, that means 2 oxygens, but this 2 here means 2 times 2 oxygens, which gives us 4 oxygens on the left-hand side. And then we look over here, and this means 2 oxygens here, but we also have 2 times 1 oxygen, which gives us 4 oxygens altogether. This 2 applies to that oxygen right there. And then we have the 1 carbon here, and we have 2 times 2 hydrogens here, which gives me 4 hydrogens. And if you look over here, you can actually match these up from left to right. We have 1 carbon on both sides. We have 4 hydrogens on both sides. And we have 4 oxygens on both sides. And when we have that situation, we say that this equation is balanced. Okay? And so that's one feature, and we have to be aware of what does it mean when we have those subscripts behind the different molecules. And that tells you how many atoms we have for each one. Now, as we look at this equation once again, after I erase my arrows, there's some key features. One is that, it has the same number and same type of atoms on both sides. Now, the left-hand side, we're going to call the reactants. And the right-hand side of the arrow, we're going to call the products. No matter what the equation looks like, whether you think it looks right or not, if it's left of the arrow, it's reactants. And if it's right of the arrow, they're products. Now, it doesn't matter about the order here either. You can switch the order around and it's the exact same equation. So like, for instance, we could write this equation as 2 O2s plus CH4. And we could also reverse the right-hand side, the products over here. So it doesn't matter. Order doesn't matter. Okay? Now, oftentimes we follow, like in a combustion reaction, we take whatever the organic or the chemical that we're reacting with the oxygen, usually it's written on the left-hand side. But that's not required. It doesn't matter. What is required, though, is everything to the left of the arrow is a reactant and everything to the right of the arrow is a product. And that we have a balanced equation, which means we have the same number and same type of atoms on both sides. Now, how do you balance an equation? So let's start with that original equation and let's figure out how we would balance that. So we have methane, CH4, plus oxygen, O2, gives us CO2 plus water. And this is a combustion reaction, which means we're reacting with oxygen and we're producing carbon dioxide and water. And so the first thing that you have to do when you do this, when you're trying to balance an equation, is it may already be balanced. And so we look on the left-hand side, and I see one carbon on the left-hand side. And I look on the right-hand side, and I see one carbon. Well, so far so good. And I look on the left-hand side, and I see 4 hydrogens, because that's what the 4 behind the hydrogen on CH4 means. And I look on the right-hand side, and I see, 2 hydrogens. Well, this is not balanced. And we can also check the oxygens, and on the left-hand side I have 2 oxygens, and on the right-hand side, and this is very important, there are 2 places where you have oxygens, and this is a common mistake, is to look only in one place. Now you got to look in everything. And so we have 3 oxygens on the right-hand side, and it's not balanced. Okay, so we need to figure out, what are we going to do to balance this equation? Now, there are several different techniques for balancing equations, and it really depends on pattern recognition. And the way you get pattern recognition is to balance many equations and just do them over and over again. You can go on the internet and you can find lots and lots of worksheets in your textbook. There are some equations to balance, but the more you do, the better off you're going to be, and the faster you'll be, and the more confident you will be. So let's take a look at this. Now, when I'm doing combustion reactions, I like to focus on what it is that's being burned or combusted. And so I look at that and I see 1 carbon, and I look on the right side and I see 1 carbon. So far, so good. And then I look at the hydrogens, and I see I have 4 hydrogens. And I look on the right-hand side and I look everywhere, and I see I have 2 hydrogens on the right-hand side with the waters. And how am I going to get 4 hydrogens? Well, if I put a 2 in the front, well, that means 2 of everything, not just the hydrogens, but 2 of everything. So now I have 4 hydrogens. So sure enough, when I look at that first molecule, I've balanced the carbons. Now I've balanced the hydrogens. And so now the last thing you always balance diatomics, which means 2 atoms, and elements or atoms last. That's a requirement. If you see O2, H2, F2, Cl2, or if you just see like Zn for zinc, you always do those last. Okay, so we've already balanced the carbons and the hydrogens, and the only thing left to balance now is the oxygens. So how many oxygens do we have on the right-hand side? Well, we have 2 with the CO2 plus 2 more with the H2O, and that gives me 4 oxygens. And so we look on the left-hand side and we say, well, what do I need to put in front of that oxygen to get 4 oxygens on the right-hand side? Well, there's 2 in O2, so 2 times 2 gives me 4. So now I have 4 oxygens on the right-hand side, and I now have balanced the 4 oxygens on the right-hand side with the 4 oxygens on the left-hand side. So this whole equation now is balanced. And so we can do that for, say, let's say we have C3H8 plus O2 goes to carbon dioxide and water. That's the products of combustion. And we do the same thing. We look at the carbons first. Let's take a look at the carbons. And I see I have 3 carbons on the left-hand side. And so I go over on the left-hand side, and I go to the right-hand side, and I see that I have 1 carbon, so I put a 3 in front of that carbon. Now the carbons are balanced. Now I look at the hydrogens, and I see I have 8 hydrogens on the C3H8 otherwise known as propane, and I look to the right-hand side and I see 2 hydrogens here, and I need 8 hydrogens. And so what times 2 gives me 8? And that would be 4 H2Os, 4 waters. And so now the hydrogens are balanced and the carbons are balanced, and the only thing left to balance now is the oxygen. Keeping in mind, we always do diatomics. O2 is a diatomic. We always do diatomics, and elements by themselves, we do those last. And so we look on the right-hand side, and we got to see how many oxygens we have. Well, the carbon dioxide has 6 oxygens, and the H2O, well, there's 4 times 1, that gives me 4, and that gives me 10 total on the right-hand side. So now we have to look and see, well, what times 2 is going to give me 10? And of course, that is 5. Now, anytime you do a balanced equation, it's not enough just to go ahead and balance it. You need to go back, and this is a critical step. You need to go back and make sure that the equation is balanced. And so we'll go back through and we're going to check. We're going to do a check. And so we say 3 carbons on the left, 3 carbons on the right. Okay. And then we say 8 hydrogens on the left, and we have 8 hydrogens on the right. 10 oxygens on the left, and we have 6 plus 4 gives me 10 oxygens on the right. So sure enough, this equation is balanced. Now, a situation that happens sometimes is that if we have an odd number of a diatomic on the left and an even number of diatomics on the right, then we can have a situation where we have to do something extra. All right. So we do the same thing that we did before, which is we say C2, and we come over here and we say 2 CO2s. Carbons are balanced. And we go to the hydrogens on the left. We see 6 hydrogens, and we go to the right and we say, well, you know what? We can get 6 hydrogens on the right, and now we're going to balance our last oxygen. And so we add them up and we say, well, there's 4 oxygens from the CO2, and there's 3 oxygens from the H2O, and that gives me 7 oxygens. Now that's a problem, because how do you get 7 out of O2? Well, you can't with a whole number, and these need to be whole numbers that we're going to put there. And so if we have odd on right, we can always make it even. We can make it even if we multiply everything by 2. Because 2 times 1 gives you 2, 2 times 3 gives you 6, 2 times 5 gives you 10, 2 times 7 gives you 14. So you can always turn an odd number into an even number by multiplying by 2. Now, to do that, though, you have to multiply everything by 2 to keep the balance. Everything needs to be multiplied by 2. So we say, well, you know what? I'm going to multiply that C2H6. Well, that's times 2. Now we're trying to get an even number of oxygen so we can balance it. So let's skip over the oxygen. And we look at the CO2. Let's go ahead and multiply that times 2. So that becomes 4. And let's multiply that 3 in front of the H2O times 2, and that becomes 6. And it's still balanced so far. We're just trying to get the oxygens to balance. Because if you look, you see 2 times C2 gives me 4 carbons, and we got 4 in front of the CO2. That's 4 carbons. And 2 times 6 with the C2H6, that gives me 12 hydrogens. And if you look on the right-hand side, we have 6 times 2 on those hydrogens, and that gives me 12. And so now we have, it's still balanced, but now we have 4 times 2 gives me 8 oxygens on the CO2, and 6 times 0 gives me 6 times 1 gives me 6, and that'll give me a grand total of 14. And that should make sense because all we did was we went through and we multiplied everything by 2. And so now we have 14 oxygens on the right hand side, and now we can say there are 7 oxygens on the left hand side. And so anytime you have an even versus odd, that's how you take care of it. Let me show you one more example of where that happens. Let's say we have the reaction of aluminum plus oxygen gives me aluminum oxide. Now, remember what I said, we always balance elements, which would be the aluminum and the diatomic. We always do those last, okay? So we're going to start with the aluminum oxide, and I see that we have 2 aluminums, and that takes care of the aluminum. Now we need to balance the oxygens, and I see we have 2 on the left, 3 on the right, and once again we're in an even-odd situation. We have an even number of oxygens on the left-hand side. We have an odd number of electrons, odd number of oxygens on the right-hand side with 3 oxygens with the Al2O3 aluminum oxide. And so we're going to do the same thing we did on the last problem. We're going to multiply everybody through except the oxygen, because that's what we're trying to balance. And we're going to multiply everybody through by 2. And so that becomes 4 aluminums. And then 2 times 1 means this is 2 aluminum oxides. Now we have 6 oxygens on the right-hand side, and we can put a 3 over here. And so now this equation is balanced. Now, here's an interesting equation that we can balance. Let's try this one. Let's say we have iron, Roman numeral 3 oxide, plus carbon monoxide goes to carbon dioxide plus iron. This is how you refine iron oxide into iron metal, is you react it with carbon dioxide. And so how would we do this? Well, I look at this equation, and a lot of times where you see an element that appears in more than one place, in other words, the iron oxide has oxygen, the carbon monoxide has oxygen, and the carbon dioxide has oxygen, you have to look at it as, where does it go? Where does it go? And so what I see here is that when the carbon monoxide becomes carbon dioxide, you're adding 1 oxygen. So for every carbon monoxide becomes a carbon dioxide, you're adding 1 oxygen. Now, where is that oxygen coming from? It has to come from somewhere, and it's coming from here. It's coming from the iron Roman numeral 3 oxide, and that is where it's going. It's going into the carbon monoxide to become carbon dioxide. And if there's 3 oxygens that have to come off of that iron Roman numeral 3 oxide, then you're going to need 3 carbon monoxides to give you 3 carbon dioxides, and that's because of the 3 over here. So where does the oxygen go? It goes into the carbon monoxide to become carbon dioxide. And so having done that, we've balanced the oxygens and we've balanced the carbons. So the carbons and oxygens are now balanced, and the only thing left to do is to balance the iron. And there it is. And we look over here, and you're going to have to put a 2 in front of the iron to balance the iron. And it's like I said, when we're doing balance and equations, the more of these you do, the more you'll see patterns, and the more you can look at it and you can see the big picture. What you don't want to do is just to put down random numbers and hope that it works, because that generally does not work. You have to look at the reaction and decide, where are things going? Now, there's another kind of reaction that we can balance, and that's involving our polyatomic ions, which we should memorize. Let's say we have silver nitrate plus calcium chloride, and it goes to silver chloride plus calcium nitrate. Okay? Now, the way you balance equations with polyatomics, in this case we have a nitrate ion, is you don't, for instance, balance the nitrogen and then the other nitrogen and then the oxygens and then the other oxygens. You don't do that. Don't do it that way. You don't want to do it that way. What you want to do is you want to focus in on how many of that polyatomic do you have. Now we can look at this equation and balance it left to right. I have one silver. Okay, I got one silver on the right hand side too. But I have one nitrate. That's an 8. One nitrate ion. And I look over here and I have two nitrates. Okay, NO3 minus. And so therefore, to get the nitrates to balance, we have to put a 2 in front of the silver nitrate. So now the nitrates are balanced, but now the silvers aren't balanced because now I have two silvers here. I only have one over here, so now I need to put a 2 in front of that silver chloride. And then I look at the calciums. The calciums are good. We have one on both sides. And now I look at the chlorines. I have 2 chlorides, and I have 2 chlorides over here. So now the equation is balanced. All right, and we can similarly do things the same way. We could have, say, let's say, what can we do here? How about a sodium phosphate? And we're going to react it with, say, let's say we react it with calcium chloride again. And this time we'll get a calcium phosphate. And we'll get sodium chloride. All right, so we need to balance this. And so one of the things that can happen here is that you have this situation where you have once again an even and odd situation. This is even odd. And just like we did crossing charges, we're going to have to cross back over, and let's see what we can do here. It should be 3. Let's see, 2 of these and 3 of these. Let's see how that works. Okay, what I did was I took the 2 and I'm going to multiply everything that has a phosphate and make it a 2, and we're going to say to 3, and we're going to make everything with the chloride. And let's see how that works so far. So we have 2 times 3 gives me 6 sodiums, and I look on the right hand side and that's 6 there. And we have 2 phosphates, that's a phosphate, and we have 2 on the right hand side. And we have 3 calciums on the left hand side. We have 3 calciums on the right hand side, and 3 times 2 on the chlorides gives me 6 chlorides, and we have 6 chlorines on the right hand side. And so I'm able to look at it because I've had a lot of practice in balancing equations, and what it comes down to is the more you practice balancing equations, the better you're going to get at it. So I would highly suggest that you go in your textbook and you balance every single equation that they give, including the examples. And I also suggest that you go to the internet and you try to balance as many equations as you have from balancing equation worksheets. And eventually, some people are really good at balancing equations, and some people, they're just going to need a lot of practice, and that just depends on you. When I was in your position, I'd had to have a lot of practice because it didn't come to me naturally. And there's if you run across where you just can't figure it out, there's actually an app. There are apps on the internet where you can enter the equation and it will balance it for you. You can use that to check your work. So there you go. That's how you balance equations.